Hello there. Welcome to Astraveo's continuing education series, where for our podcast listeners, we talk about mathematics, the physical sciences, of course the natural world, and our personal favourites, astronomy. Now, you know Joseph and I are all up in and about astronomy. We get super excited about that stuff. So let's get going. Welcome back to Astraveo's continuing education series. And for today's episode, we're going to be talking about the equation of a straight line. Now, this is really fundamental in all kinds of fields in terms of science, engineering, construction, manufacturing, architecture, farming. And it's really quite a simple process, and it comes all the way back probably from Euclid, a mathematician from 2,300 years ago. He comes from ancient Greece, as many of those philosophers of the time did. But over the years, his theories that he produced in the Elements, a series of books about geometry, have been refined, and now we have a very simple equation for a straight line. And here's what it looks like. It can be generalized, and I'll explain all the symbols in a second. mx plus c. Sometimes this C is written as B, it depends which country you're from, which culture you grew up in, which education system you're part of. But the generalized expression can be written as Y equals mx plus C. And I'm going to explain all this on a graph shortly, but this is it's called the intercept line, interceptor line. And it's basically the Y value when x equals 0. This M symbol, this is called the slope or the gradient of the line. And you can see it quite nicely if we draw a Cartesian grid, a coordinate grid. And so I'm going to draw it as best I can. I'm not the world's best drawer, but there you go. Okay, sorry. This axis is normally x, and I write my x's a little bit funny like mathematicians do. And this axis is y. Now this point here is called the origin, and its coordinates are 0, 0. That means the x value is 0 and the y value is 0. So this line here, the y-axis, is any point at which x is 0. X is 0 here, 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 at the origin, here, here, here. On that line, x is always 0. Now the converse is true for the x-axis. Anywhere along this line, y equals 0. Y is 0 here, 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 at the origin, here, 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 everywhere. So that's why the point at which x and y intercept is called the origin, where x equals 0 and y equals 0. So I'm just going to draw an example line. Okay, I'm going to take any old line and I'm going to draw it like this. Now we have a couple of very special points. We defined here the parameter c as the intercept line of where it equals x equals 0. This is the x equals 0 line. It intercepts there. So whatever that value is, that is c. Okay? Now here, you're going to have let's just say you have a data point up here. Now we don't know what it is yet, but let's call it x2, y2. Now it could be anything. X could be 5, y could be 4, could be 3, depending on the data point, but it has some x value and some y value. Now we could choose another point on the line down here, and because it's smaller, which I bet you're wondering why I wrote x2, y2, because the values are smaller, they're closer to the origin, I'm going to give it the label x1 and y1, and you'll see why shortly. x1, y1. Whoops, there you go. So now we have several parts of the graph that we can now start to understand. We've already described c, the y-intercept, that's when x equals 0. We have an x number and we have a y number because it depends on the x and y axes on the graph. Well, we still have this m, the slope. Well, look, we can see the slope really quite clearly here. This is the slope of the line. It's just how steep the line is. Well, we have a special way of measuring it. We're going to draw ourselves a little triangle, like this. You can make a right angle triangle if you wish, right there. Now, this distance is the change in y from this data point to this one. This is the difference from here to here on the y-axis. So here we can call this change in y. Now the same is true for this distance, except this time it's moving along the x-axis, so we can call it the change in x. Change in x. So now we can come back to our equation and we can define the slope or the gradient, the m, as the change in y divided by the change in x. So it's actually quite simple. This slope is really how steep there is a change in y divided by the change in x. So we have a formal definition of the slope now. The change in x over the change in y. When I say over, I mean divided by. And this c here is when the line crosses the x equals to 0 line, which is the y-axis. So we have an equation of that line. Now, let's do a practical example because that can be a little bit confusing. We're still in a sort of theoretical world here. I'm going to leave this diagram up, I think. Let me get rid of my equation, but I'll rewrite it so we don't forget. Okay. So, y equals mx plus c. Don't forget c is just where the line intercepts the y-axis, the x equals 0 axis. And m is the slope, it's just the change in y divided by the change in x. So let's have a real example now. We want to find the equation of a line that looks like this. Whoops, my pen is squeaking, I do apologise. Now this time, I'm going to do almost exactly the same line actually. Whoops, still very squeaky. But this time I'm going to put some numbers. I'm going to do 0, 0 because that's the origin. I'm going to give this a 1, 2, 3, 4, and 5. And I'm going to do the same here. I'm going to call this number 1, number 2, number 3. I'm going to come inside the graph because I've run out of space. 4 and 5. Now automatically we get a free number. And I'm going to use a different colour pen just to make that clear. What do you think this number here represents? That's right, the line crosses the y-axis, the x equals 0 axis. So automatically we know that c has to equal 1. Because it crosses y equals mx plus c, we define c as the intercept point on the y-axis. So we already know one of the numbers of our equation. Now, really, we need to know the slope. So I'm going to give you a couple of data points. I'm going to give you one here. This is we're going to be, it looks about right, 5, 5. And it's always written x, y. So this is 5 units up approximately. It's hard to see with my graph. This is 5 units in x with 5 units in y. Now let's do another number. Let's make it really simple. There's another number here. I'll do it about there. My drawing isn't exactly perfect. 2, 2, xy. So how do we work out the slope of that line? That seems to be perhaps difficult. But don't forget, we told ourselves that the slope of the line is just the change in y, divided by the change in x. Well, that's actually quite easy to work out. But don't forget, this is x2, y2, and this is x1, y1. So now we can work out the change in y is just y2 minus y1 divided by the change in x, which is x2 minus x1. Well, we have all those numbers on the graph. We can now work this out. So m is y2, which is the number 5, minus y1, which is the number 2, all divided by x2, which is the number 5, again, because I've used the same points, minus x1. x1 is the number 2. So now m is 3 divided by 3, which equals 1. So now we have the equation of our line. we have y equals mx plus c. Now we know c is 1. We did that by design to make it easy. Now we also calculated m, the slope, and it also turned out to be 1. So our equation is y equals 1x plus 1. Now 1 times x is just x. So the equation of our line is actually y equals x plus 1. A very linear equation. Linear means x and y scale with each other. And you have this very nice equation that crosses the y-intercept at x equals to 0 and y equal to 1. Now in the real world, how is that useful? Well, let's talk that through just a little bit. I'm going to leave the graph up because I like the graph being there. It's very demonstrative. Let's say, for instance, you start here and somebody says, well, if you walk 5 miles this way, and you know the equation of the line to your destination, you're going here. If you have to walk 5 miles, let's call this east, you also might want to think, well, how far north do I have to walk to get to this destination? Well, if you could draw out your destination, your journey beforehand, you could work out, well, if I have to walk 5 miles east, and I know the equation of this line is y equals x plus 1, what we could do is say, well, I know the equation is x plus 1. X is 5. And so what we're going to do is say y equals 5 plus 1, y equals 6 miles. I have to go north 6 miles. Now obviously if you walk east 5 miles and north 6 miles, you're going to be very tired. What you really should do is walk along the hypotenuse, so that's the shortest distance between 2 points. But the point being is, an equation like this, if you know the equation of a line, it can really save you some time in terms of distance, direction, if you're, say, going on a long journey. Turns out to be really useful in science, in mathematics of course, but things like farming, pharmaceuticals, art and that sort of thing. Okay, thank you for joining us.